Now we are in dumb things I did yesterday. Why? Hello, I'm Dimanari and I have Uiopik with me.
Yo, what's up, guys? How's it going? Today I'm with Daima, and we're gonna review his code on uh
A file system.
whatever file system. Yeah, I'm gonna help him. Like, I know nothing about programming, but I will be here for him.
Well, you do know something about programming. You did make a game in this. Like, what
Okay,
was it? It
let's not talk about it.
it was that much of an embarrassment.
Yes. Okay. Let's just jump right into it.
Okay, so basically a file system takes the disk, take your physical disk, and manage the data in that disk so you can read and write files and actually have access to something that is coherent in your storage.
So just like Windows's Explorer.
Yeah,
All right.
you see that I actually have a reference to Explorer here.
Oh, I see. I see.
You have the file explorer and the file system. The Explorer explores the file system, and the file system is like what manages the actual files. Any questions so far?
Um, Explain to me what is happening right here.
Okay. From your experience with code, you know that there are functions
I
or
do know there are functions. Yes.
functions, methods, or
Procedures. Yeah.
procedures. Yeah, all of those.
Yep.
This has been so long ago that I can't remember the names. So in C language, you need to declare the functions, how they would be executed in an external file so that other C files have access to their signatures. It needs to know what each function is looking like, so when the linker tries to combine all the files, all the object files, it knows what function is where, because each file contains the function within it and the function that it requires from outside. And then the linker just looks at those tables and solve those connections.
All right. All right.
And this is why everything is declared within a file. This file specifically holds all the methods that correlate to the file system itself. This is why every function in here starts with file system.
Okay.
This makes it also very easy to understand what is going on within each function. File system creates the file system. File system erno returns the errored value of the file system. If any error happened, it would be written into the erno, and then you can retrieve it with this call. File system destroy is destroying the file system. If you allocate memory, you need to be responsible and to release it back to the system. So when the file system stops functioning and you don't need it anymore, which doesn't happen in actual operating system, this is just for stuff that is in virtual disks and stuff like that, that you actually need to free the memory eventually, you would be doing the file system destroy function so the system has access to that memory again.
All right.
Free block would free the block. Find free block would find a free block and gives you its ID. Get is used is finding if a block ID within the file system is used by anything. Capture block is the opposite of free. It captures the block and now it's no longer a free block. File ID from directory takes basically the file name that you're looking for inside a directory handler, and uses the file system to retrieve the file ID. And with file system get block, you can actually get the block from the block ID of those things. You can get the direct handler to the memory. Get root directory basically gets the directory data of the roots, the lowest area in the file system. For instance, in Windows, you have your C directory, and C directory is a root directory. It's a root directory for a certain partition. In Linux, your root directory is basically just called slash.
Oh, yeah.
Empty block takes a block handler and just empties it from all data. This is used when you're making an actual file and you don't want your file to be filled with garbage. And then there is file system add to folder. Because folders are a directory data structure, you need an actual function to add things into the folder. So you take the directory data and you add to it a file with a file name, file type, and block ID. And a make directory basically does the same, basically makes an empty directory inside a block ID. So in order to navigate the file system, you have an explorer. And basically an explorer takes a file system. With that file system, the explorer can do stuff like see what is in the file system. It can print the current directory.
So just like a search bar.
No, this is just print the current directory. This is what when you have a folder open in your explorer, it shows all the files and the directories inside the folder.
I just don't understand like how it's working.
Oh,
Why'd you put like after like void explorer print there?
oh,
Then
okay. So basically, in order to create the explorer, you need to know what you are exploring. You are exploring the file system, so you give the explorer the file system to explore. When you print the directory, the explorer holds what directory you are currently in. So you only need the explorer to print the current directory. When you open, you take the explorer and you tell it, open this directory within my current space, and then explorer back tells the explorer, go back up one directory. Okay, when you do explorer make folder, you take the explorer and you tell it make a folder with this name, and then give me back a handler, a pointer basically, to where this folder is, to the data of the folder.
Alright, yeah.
Yeah, so this actually returns directory handler. I should change it because that would be more explainable. And a file returns the same type of handler, but because file doesn't have a specific way to handle it, it returns a void pointer. And basically void pointers are it's whatever you want it to be of the C language. That explains why everything is like it is.
Yeah.
Yeah, okay. So let's see how it's actually being used. I have my main function calling the menu function, because it's main menu. Yeah. So in the main menu, I I start by creating the file system and the Explorer. The file system basically uses blocks of 1 kilobyte and use 1024 blocks of 1 kilobyte, creating a 1 megabyte file system. Let's just start it up and go over. Yeah, and go over what it does. So we are currently within the menu. The menu is getting an item that you press into the keyboard. Like for instance, I press 3, it creates it goes into new item. And then new item asks me, what do I want to do? If I want to cancel my operation and return back to the menu.
Yeah.
If I want to make a folder. And it creates
a folder.
Yeah, or if I want to make a file. And it creates a file. And I can also, basically this was very simple, right? Just 3 things. It uses the make folder, make file by getting the name, ask you what did you choose. Basically it does everything like that. You don't need to understand everything to understand everything that happens. And second is open. So open, you press 1, you go into this function. Basically ask you to give your file name, but it's supposed to be folder name, but I didn't think about it too much and wanted to eventually have it more robust. So when you open a text file or some other file, it opens a text editor and you can do stuff. But currently it just lets you open folder, and then now you're in root. Inside root you're in DOM. So now we are in DOM. We can do whatever we want. We can make another folder. DOM things. We can still open things. Now we're in DOM things.
Create a file.
Okay, create a file.
Name it.
I did yesterday. .y. Now we are in dumb things I did yesterday. Why?
Yes.
Okay, so now back is really, really simple. It's just calling the Explorer back. And now we are back in dumb. No longer in dumb things. And we can go back, and if we try to go back, it does nothing. And this is because I had a sanity check for if someone tries to go back when they are already inside the root directory. Basically, currently, let's debug this. And I go back. You see that stack at is equal to -1, so it returns. This is because we are in the root directory, and then everything just stays the same.
Alright.
Yeah, this is... And now this is everything there is to this, like, rudimentary file system. So let's go over what is in the Explorer. The Explorer basically holds a handler that points to the file system. It holds the stack at that tells it on what depth of directory it is, starting at -1 being the root directory, 0 being the first folder within the root directory, and so on.
So the limit of how many directories you can have is the integer limit.
Yeah. No, the limit is currently 63. You see, max directory
Okay.
depth 63.
What if somebody wants to have 100 directories?
It's not the amount of directories, it's the depth. If you have
No.
60, if you have a nested folder within a nested folder, we need a nested folder for the 64th time. I don't know how to handle that. Why are you doing this to me?
Well, there we go. One bug.
It's not a bug, it's a
fix that. You
No,
can fix that, right?
no, this is a feature. Because this is a rudimentary file system. It's not some...
Stupid feature, bro. You're limiting us.
Do you know what is the directory depth of Windows?
Nope.
Do you know there is a directory depth to Windows?
I'm gonna create as many folders as I can right now.
Because there is directory depth to pretty much any file system, if I remember correctly. And some of those are absolutely absurd, while other ones are closer to what I did. The reason why I did it is because I want to keep this file explorer to a understandable size. You see the size of the file explorer currently?
Yeah.
It's 1 kilobyte. It can fit within one block of my file system. And basically it has 63 stack datas that holds the block ID of the item, like of the current directory, and the index of where it is. Within like the current directory. So if when we were in DOM, this would have been the this would have been like something, I think it was block 1 or something. It's basically the second block because it was the first thing we allocated after the root directory. And the index would be 0 because when you go into root, the 0 block, basically the 0 index directory within the folder here, directory data. Okay. So the first directory, which is the 0 index, would have been DOM. It's there so I can access things immediately and that I can open them immediately.
Alright.
So when I create it, I allocate the data. You don't need to understand this to know what it does. It just give me I just tell the system, give me access to enough memory so I can do my bullshit. Then I set the new file system inside the Explorer to be file system and stack it to the current root, and I zero out everything else. This can be removed, it doesn't really matter, but those two are important. When I do Explorer current directory, if the stack at is at -1, it gets the root directory because we don't have anything. Otherwise, it goes to the stack at location of the, come on, stop jumping. He goes to the stack at location and gets the block ID of that location to get the block. And that block is a directory, of course, because the Explorer can only open directories. It would launch something else if it wasn't a directory. So we know that this is a directory data, and we return it as the current directory to whoever asks for the current directory. Then if I want to print everything, I get the Explorer current directory, and I print the directory. But before I print the directory itself, I print the path name. Path name says current directory / and then for every item on the stack, it checks for the name of the item. Basically, it goes to directory pointer, which is last block. The first block in the system is 0, which is the root directory. So within the root directory, you get that root directory, and you ask for the index for the stack at that location.
Wait, wasn't -1 the root directory?
The index of the root directory was -1, but the block ID for the root directory is 0. Yeah. Yeah, I know, it's a bit sneaky. The first thing it does, it goes to the root directory, and then it says, okay, within this root directory, I know the index of the first stack item, which is 0 index. The index that it holds is the index within the root directory. So give me the file name in here. Then update the block ID to the block ID of that same stack item. And go back. So when we were inside the DOM things, the string was actually constructed like this. Yeah, so we have the root, and then the root, we ask for the index at the stack. The index said, okay, index 0 inside root. What block? What is the name of this thing? Oh, it's DOM. So let's print DOM. Then get the block ID of DOM. This is the block ID of DOM. Go back to the start because we still have items on the stack. Then, okay, get the block. What block is it? We are in folder DOM. What is the index that we are pointing to? We are pointing to the first index, which is 0. So index 0 within DOM. What is the file name? Things. What is the block ID of things? Then we go back, we see, oh wait, we are at the end. Print a new line. And then we finish everything.
Alright.
And after that, we print the directory. Printing the directory is just asking how many files in this directory, and then taking every file in the directory and just print the file.
So basically, how many files and what files?
Yeah, so for each file, we get the directory index of that file, because this is what this does. And basically, we take the file name and the file type and print name and then dash directory or file. What happens when we open a file? We take the name of the folder that we try to open, and we take the Explorer gives us the current directory, and then we ask the file system, can you give us file ID from directory?
Okay.
Which is basically the block ID that is held within the directory. And then we take the file system that the Explorer holds the handle to, the current directory, and the folder name. This gives us the target block, and we check for errors.
What's an error? What could be an error?
So what happens when we didn't find the file? What if you are trying to make a folder open on a text file?
Oh.
This is another error. So we check for the error. OFS is operation in file system. So basically the last operation in file system is a directory, which we got the ID. We ask if it's if the operation in the file system is a directory. Then we open the directory as it is. Like, if it's not a directory, we handle the error by just returning and doing nothing, because this is not a full Explorer. It's not even optimized correctly, because it still uses folder names and not folder index. It would be much better if it would use folder index, because then it would be immediate. I wouldn't have this file system file ID from directory. I will have just a file ID from index, which is, instead of going in a for loop over every item, it would just go directly to the entry and will just take it out. Current directory, now it's searches within the directory for basically the index. So it would know both the block ID and the index. And it advances the stack. If the stack was at -1 and we opened DOM, it would be at 0. And then stack data 0, which is the first entry. Block ID would be the target block ID, and index would be the target index. And those things we used at the print file and print path. Explorer back basically takes this stack at and decrease it, unless it's already at the lowest level. And then Explorer make folder. We take the current directory. We find a free block within the file system. And if the file system is full, basically we couldn't find a free block, we say fuck. And we return nothing. And then we ask the file system to make a directory at this file ID. If the file system can't, we once again say fuck. If it can make it, we add this new folder that we just made into the current folder, into the current directory. And it's the file system add to folder. And then we return this handler. Okay, so make file. Same thing. Explore current directory. Find free block. Now it's capture instead of make directory.
Why?
Because a file can be whatever data that you want it to be. I don't need to make the directory file structure within a generic file. So I just capture the block and then I empty it later on. So it's an empty file. Basically, if the block operation was okay, I add the file to the folder, and then I get the block, I empty the block, and I give you the block. Now you do whatever the fuck you want with it. It's not my problem anymore. And this is the entire code of the Explorer.
Just to create files.
Yeah, just create files, create folders, and go back and forth within them.
Alright.
Yeah, this is the simple part. Now we need to go deeper into the file system itself. file system basically holds a little bit of data. It knows the block size, the block number, the data, the block area start, and then the erno. So block size is how big every block is. Block number is how many blocks we have. The used bit field is basically a field of data that says for each block, is it captured or freed? The start data is once again a pointer handler for the block area. Okay, so basically when I create a file system, I do the initialization stuff. I zero the bit field, so all of the blocks are free, and then I capture the first block for the root directory. Erno basically get erno and reset the erno so that I already took the error value away. File system destroy just frees the data so the system can use it again. File system empty block basically just does a mem set to 0, basically sets all of the data within the block to 0. It takes the block address and the block size. File system get block basically checks if you are doing stuff that is not stupid, and then it just takes the start address and gives you the location offset in block ID and block size from that start address, which is the correct location of your block. Basically returning the handle of the data within a certain index. But because this is a C, you also need to know the size of each block that you're skipping, because it's not something that is handled within the language itself. Because C is very nice like that. It loves you. It loves to give you all the freedom to make the dumbest mistakes in the world. File system get root directory basically does this file system get block, but with block ID 0 as a static thing. File system open file from directory basically ask for the file system to get the ID of the stuff and get the block. File system ID from directory is the stuff that we already looked at in the Explorer here when we wanted to open a directory. We use this. So basically it goes into the current directory, compares the file name with the file to open. strn compare basically is compare two strings. The first string is the file name that we are currently looking at, and the second thing is the file to open.
You're just comparing those two, and if they match, you open them.
If they match, I open them and set erno into the file type. I'll need to change the erno values to handle better file types, but currently this is what it does. And then if it didn't find anything, we said the last operation did not find anything and return a -1. Because size t is an unsigned value, -1 just makes an unsigned overflow. And basically the value itself is 2 to the power of 64 minus 1. Yeah, I can see the like, what the fuck. But this is how computers work. Yeah, find free block. The same idea as before with the -1. Do you remember how numbers are set within the memory? If we have 8 bits, how would you represent 1?
0, 0, 0, 0, 0, 0, 0, 1.
How do you represent -1? No, you make a number that when you add this 1 into, it would become 0. Because you only have 8 bytes. What happens when you remove from this 0, you remove a 1? You borrow another bit from here, and this is your 0, and you remove a 1 from that, and this would equal to basically you borrowed this 1 from the next block over, so it would be 1, 1, 1, 1, 1, 1, 1, 1. And this is -1. Okay, what happens when we add it? It becomes more clear when we add -1 plus 1.
Okay.
This bit plus this bit is giving us 0 and carry up.
Yeah.
So we carried. Now we have 0 here, 1 here, and we have a carry. What does it do? It adds a 0 and we carry up again. Third bit. 1, 0, and we carry up.
So it's just a bunch of zeros.
Yeah. This is why I said coding magic.
That's okay. Yeah. Understandable.
Yeah, so this coding magic actually is not really magic, it's just math, but it's stupid computer math that doesn't work anywhere else. And the current index is this. While the current index is still smaller than the block number, meaning we are not at the end of the file system, and the current block that we are looking inside the bit array is full, we advance the current index. There are only two endings to this loop. Either we reach the end of the bit array, meaning that the entire file system is full, or we find a single block that isn't full. If we did find that there is no space within the file system, just file system full, we couldn't find anything. And if we found a non-full block, we get the value of each bit within the bit array, and for the first bit that we found, the free block that this bit points to is this calculation. Basically, this is the offset to the start of the bit field, and this is the index within the bit field. This would give us the current block ID that we want to look at, and then we return it. And then file system free block. Basically, we take the block byte location and block byte index, because char bits will always be 8, will always be a power of 2, and bit array size in bytes is also always a power of 2. The multiplication would also always be a power of 2, so when you take a power of 2 and you reduce it by 1, just like this thing, it would always be a set of 1s. So instead of doing a modulus, I can do this operation, and basically it gives me the internal index. This isn't the correct way to do it if the bit field was on arbitrary size, but it works with basically every data type within the 86 architecture, and basically any modern architecture as well. But basically just get the location within the bit field and the byte index, and we get the value. Basically, if the block ID is bigger than the block number, we return a fail, because we are trying to access a block ID that doesn't exist. When we know that the block ID does exist, we look inside the block ID and get the value of the index itself, and we know if it is already used. And if we've tried to free a free block, we return block operation is already at status, meaning that you can't free again a free block.
It's already free.
Yeah. So if we need to free the block, then we set the bit off and tell the system, okay, we freed the block. The block is now free. Same thing happened with the capture. It's just the same function. It's the same function, but instead of on, it's off. Instead of not use, is used. Get, if the file is used, it's just taking the byte location and byte index and returning the value. But we don't want to calculate again. This is just basically for stuff that only need to know if it is used and doesn't need to do it for other stuff. So there is like code duplication here, which is why I needed to fix this same bug 7 times. Well, 3, but could have been 7. Might as well. Make directory basically just does the capture block, like when you make a file, and then gets the block and sets the files in directory within the handler to be 0. So all of the garbage data within this block is just ignored. And when you add a folder, you already override everything, so it doesn't matter. Yeah, and basically max files in directory calculates the maximum files within a directory. This is when you try to add a file to an existing folder, like you try to add something new into a folder, you need to know that there is still space. So if you do this, 1024 minus 8, and then divide by 72, you see that there are 14 files that can fit in a directory. And this is a bad limitation, but it can easily be solved later. So this is the entire file system.
Alright. That was actually not as much as I thought.
Yeah,
Pretty simple, to be honest.
yeah, I know. This is just like that moment of watching a Mambo Jumbo episode and doing it alongside, when you're like, this is actually not that complicated.
This actually makes sense. What the hell?
Yeah. And then you enter beta ray and you look at it and you're like, what the fuck even am I looking at?